December 1st, Introduction to Function Notation. If we have a set of operations that we perform on whatever number we put into it, we call that a function. If our function is to take whatever number we put into it and add 2, our function would be x plus 2. We also want to be able to talk about more than one function at a time, and we use letters to refer to whatever the function is. It looks like this. F of x is equal what we're doing. Or for example, f of x is equal to x plus 2. The f can be anything. We just use it as a name. Whatever it is in the parentheses is what we put into the function. Using the example above, for f of x is equal to x plus 2, f of 3, we plug that 3 in for x. So it's 3 plus 2, and we get 5. Using that same equation, f of 4, well, that's 4 plus 2. We plug it in here. So it's 6. F of negative 3, that gives us negative 1. 18. 1/2 plus 2. What do you think? 5/2. F of y, doesn't matter that it's a variable. It's just y plus 2. But now we have some different functions. We have f of x is equal to x minus 3. We have g of x is equal to 4x. And h of x is equal to 2x plus 1. So for the different letters, we're going to plug in differently. For example, f of 4 becomes 4 minus 3, which is just 1. F of 0 becomes 0 minus 3, which is negative 3. F of negative 4 becomes negative 7. X minus 3, and 4z minus 3. Switching to the g function, I'm going to multiply whatever is in the parentheses by 4. So this gives me 16, 0, 4y, and let's move on to the h function. Negative 2 times 2 plus 1, because I double it and then I add 1. So negative 4 plus 1, negative 3. 0 doubled plus 1 is 1. 5 doubled is 10, plus 1 is 11. So this becomes 2 horseshoe plus 1. You can use anything. The top part on the back is more practice of the same, but the middle part changes a little bit. For example, we know that g of x, which is the function negative 3x plus 1, is equal to 16. And now we have to find x, so it's back to solving equations. Minus 1, negative 3x is equal to 15. Divide by negative 3. X is equal to negative 5. Which means if we were to take f of negative 5 and plug it into that equation, I'm sorry, this one was g, right? So we'll say g of negative 5 and plug it into that equation from the start, we would get 16. Same idea here. We start with negative 2, and it's equal to the 12 over x from earlier in the problem. So what value can we plug in for x to make this true? Well, we can just solve it if we want. We can multiply both sides by x, and we have negative 2x is equal to 12. And when we divide by negative 2, turns out negative 6 would have done it. For this one, we know that x squared plus 7 is equal to 23, so now we need to find x, or find x if f of x is equal to 23. We subtract 7 from both sides. X squared is equal to 16. So we take the square root of both sides, and x is plus or minus 4. We'll do a few down here at the bottom. If g of n is 4n minus 5, well then we take 4 times 6 minus 5. 24 minus 5, which is 19. This becomes 2 squared plus 4 times 2. We replace every n with 2. So this is 4 plus 8, which is just 12. Negative 3 times 2 squared minus 5 times 2. So 2 squared is 4 times negative 3 is negative 12 minus 10, negative 22.